like, share, subscribe.
Hey y'all, welcome back. In today's lesson, we're still kind of focusing on linear functions, but with an emphasis on parallel and perpendicular lines. So to tell whether or not lines are parallel or perpendicular, we need to know a little information about their slopes. And these first couple of questions are just asking about average rate of change or the slope of these particular lines. So number one says the data below represent the maximum number of heartbeats that a healthy individual should have during a 15-second interval of time while exercising for different ages. Compute and interpret the average rate of change in the maximum number of heartbeats between 20 and 30 years of age. Okay, so the average rate of change. When it's asking about the average rate of change, what it's really asking for is the slope between those 2 points. So it says between 20 and 30 years of age. So in this table, we're really just going to be looking at these first 2 data points. Okay. So these two, in this table, these are 2 data points that we can write as coordinates. It's a little bigger here for you. 20, 50. And 30, 47.5. I'm going to compute the slope using change in y over change in x, just kind of the same way we did in class. Our change in y is going to be the change in the y value. In other words, how do I get from 50 to 47.5? And I'm going to call this my delta y, or my change in y. So delta y. And yeah, to get from from 50 to 47.5, we need to subtract 2.5. Now, the change in x, okay, the change in the age, change in our independent variable here, is, see, from 20 to 30, we got to add 10. Okay. So just to make this real clear, what we're calculating here is the slope of the line that contains these 2 points. Okay, that essentially is going to give us our rate of change. Now to calculate rate of change, or the slope, which is something we'll have to do to determine when lines are parallel and perpendicular, it's the change in y divided by the change in x. Or if you're thinking about it visually, it's rise over run. So we already have these 2 values here. The change in y was negative 2.5, and the change in x was 10. So this is our rate of change. We can go ahead and just compute this, throw this in a calculator, and you get negative 0.25. That is the average rate of change in the maximum number of heartbeats between 20 and 30 years of age. So we want to make sure that we're answering the question that's being asked, and a lot of times that just is a matter of sort of rewriting the question as a statement with the answer you got. So I'm going to say something like this. The maximum number of heartbeats decreased by 0.25 per year between the ages 20, 30. Ages of, grammar there I'm a little shaky, but that's kind of the idea here. Basically, you're trying to communicate that as you get older, the maximum number of heartbeats is going to decrease. Okay, so that's number 1. Let's take a look at number 2, which I think is going to be a very similar problem. It says the following data represents the weight in grams of a box of raisins and the number of raisins in the box. Okay, so we would expect that if there's more raisins, the weight is going to be more. Right? Compute and interpret the average rate of change in the number of raisins between 42.3 and 42.5 grams. So we're going to be looking at these 2 data points here. Just like in the last one, we're looking at the first 2 data points, but you kind of have to look at the question to see which ones they want you to look at, because this may not be perfectly linear data. So we're going to kind of do the same thing that we did in this last problem. So actually, I'm just going to copy and paste this just to kind of save a little bit of time here, because the format of how I'm going to answer this question should be basically the same. Okay, it's just that my data points are going to be different. Okay, with these raisins. Okay, when the box weighs 42.3 grams, we are expecting 82 raisins. And when the box weighs 42.5 grams, there are 86 raisins. And so let's look at the rates of change here. Now, if you're not really sure, well, this one's pretty easy, right? From 82 to 86, my change in y is going to be plus 4. But feel free to use a calculator if you're just not sure. You can just subtract, 86 minus 82 to get this. When you start having fractions and decimals and negatives, it's not a bad idea to throw it in the calculator. But these are pretty simple, right? 42.5 minus 42.3 is just going to be, we're going to add 0.2. And that should be changed to x. Did I not? Yeah, I forgot. I messed that up over here. This should be changed to x. Okay, so let's see, where are we? So the slope is the rate of change, which is the change in y, so that's going to be positive 4 over 0.2. Okay, and what we're calculating here is the average rate of change in the number of raisins between these two weights. So 4 divided by 0.2 is going to be 20. You can throw that in your calculator if you can't compute that on your own. So yeah, let's go ahead and write our final answer here. Okay, we can say the number of raisins increased by 20 for each gram of added weight. Okay, so yeah, the number of raisins is going to increase by 20 for each gram of added weight. Okay, the raisins don't weigh very much, so it takes 20 of them to increase the weight by 1 gram. Okay, there's number 2. Let's take a look at number 3. The relationship between Celsius and Fahrenheit degrees for measuring temperature is linear. Find an equation relating C and F, the Celsius and degrees, if 0 degrees Celsius corresponds to 32 degrees Fahrenheit and 100 degrees Celsius corresponds to 212 degrees Fahrenheit. Then use your equation to find the Celsius measure of 60 degrees Fahrenheit. So first, let's come up with our two coordinates here. So they say, 0 degrees Celsius. So I'm going to start with my x being Celsius, so 0, comma, 32 degrees Fahrenheit. Notice how this is going to actually be our y-intercept because it's the x is 0 here. And then 100 degrees Celsius corresponds to 212 degrees Fahrenheit. So here are the two relationships that we have. We can find the average rate of change. We already have the y-intercept, and really that's all we need for the equation. All right, we've already got the y-intercept. We just need to find the slope here. We're going to compute the slope just like we did before. Find the change in y and change in x. Go ahead and just copy a little bit of this. We're going to be doing pretty much the same thing here. And, delete stuff. Don't need any of that. Okay. So yeah, my change in y from 32 to 212, and you can just subtract this if you'd like. 212 minus 32, that's going to be 180. And then going from 0 to 100, well, you just have to add 100. That one's a little bit more obvious. Okay, so my change in y over change in x is going to give me my slope or my rate of change. My change in y was 180. My change in x was 100. And you can let the calculator reduce this for you, but it reduces to 9/5. So that's our rate of change. Notice here that 0.32, that's our y-intercept. So that's kind of nice that we're given that. So we got our slope, we got our y-intercept, so we can go ahead and write our function. So y equals 9/5 x plus 32. Now, we're talking about converting Celsius into degrees, so it might be nice to use variables in our equation that relate to what we're trying to represent here. So our change in y, 30 and 212, those are degrees Fahrenheit, right? So that means that our output here, our y, should be Fahrenheit, and our input here, these are the Celsius degrees, so I'm going to put C here. Okay, so the change in y, you can think of that as the change in F. Okay, the change in X is like the change in Celsius. And I just think this will, kind of help make sense of it a little bit more. All right, so there's our equation, and now we can use it to convert, right? We want to find the Celsius measure of 60 degrees Fahrenheit. So if the Fahrenheit is 60 degrees, what is the Celsius temperature? And we can use this equation for that conversion. This is actually the real conversion here. So we want to solve this equation. We're going to subtract 32 from both sides. So 60 minus 32 is going to be 28 equals 9/5 C. And then we want to, it looks like, divide both sides by 9/5. That would be equivalent to, say, multiplying by 5 and then dividing by 9. And it looks like we get, I've got a calculator running over here, 15.5 repeating. So the Celsius is going to be 15.55. I'll just, round up the third decimal point so I don't have to go too far here. This is going to be approximate because we are rounding. You can even, you don't really have to go this far out. If you just want to say 15.6, that's good too. And that's going to be degrees Celsius. Okay. And because we have our units here, we don't really need to go into more detail with our answer, but I'm just going to say something like 60 degrees Fahrenheit is equal to, or I should say equivalent to, probably a better word to use there. Let's see, probably misspelled there. There we go. Extra R in there. 60 degrees Fahrenheit is equivalent to approximately, because it's not exact, 15.6 degrees Celsius. Well, Celsius, C-E-L-S-I-U-S. There we go. All right, so there's our answer. That's the answer for number 3. Okay, so just a couple of word problems to start this off. I don't want you to lose track of how to interpret these word problems, these stated problems. That's going to be a recurring theme throughout this year that we're going to have a lot of word problems to interpret. Okay, so let's move on. What type of line has one x-intercept but no y-intercept? Let's try to sketch that out just to kind of see what I mean here. How could I draw a line that has one x-intercept, so it crosses the x-axis, but no y-intercept? The only way for that to happen is if it's a vertical line. Right, and any vertical line would satisfy that, but it would have to be vertical in order for it to not cross the y-intercept. The next question is very similar here. What type of line has one y-intercept but no x-intercept? So same kind of idea here where we have a line, it's got a y-intercept, but it cannot ever touch the x-intercept. The only way for that to happen is if it's parallel to the x-intercept or horizontal. So we'll just say a horizontal line. Number 6 says, write the equation of a line that's parallel, okay, we'll talk about that in a second here, to y equals 5x plus 2 and passes through the origin. So these are my two pieces of information. The fact that it's parallel means that it's going to have the same slope. Okay, so I'm going to just make a little note here. Parallel lines have the same slope. You probably have that written down in your notes somewhere. But I just think it's good to just make a note here as we're working through these parallel and perpendicular problems. So the slope of this line is 5. So we know that when we write our equation, going to be y equals 5x plus whatever the y-intercept is. Now it says it passes through the origin. The origin is the coordinate 0, 0. Okay, it's that point right in the middle where the axes meet. And so in our y equals mx plus b equation, we have like plus 0 here, but you don't need to write the plus 0, so there is our equation. It's parallel to this, but passes through the origin. Number 7 says, write the equation of a line that's perpendicular. So this one's going to be perpendicular to 5x plus 2 and passes through the origin. So this one also is going to have that 0 y-intercept. Perpendicular slopes, on the other hand, perpendicular lines are ones that cross at 90 degrees. If you want a little bit more information about parallel and perpendicular lines, check out the notes video that will exist in the future, I guess. Just, I guess if you're watching this on YouTube, there isn't a video yet, but hopefully in the near future there will be. Okay, so perpendicular slopes are opposite reciprocals. Okay, meaning like if one is 2/3, the other one's negative 3 over 2. So if this slope is 5 over 1, then the perpendicular slope would be negative 1 over 5. So that would be the perpendicular slope. The origin is that 0, 0 point, so the y-intercept is just 0. So here's our equation. Okay, that's it for the first page. Let's take a look at page number 2. So these couple of questions here says, determine whether the linear equations are parallel, perpendicular, or neither. So we just got done talking about how to know when they're parallel or perpendicular. So that's what we're looking out for. We're looking for the slopes. So as soon as we have the slopes, we should be able to answer this question. Number 8, both of these are in slope-intercept form, so we can see the slopes right there explicitly, no manipulation required. They are the same, so we can conclude that these slopes are parallel, or the lines are parallel. If we look at number 9, and we take a look at those slopes, we got 3 and negative 1/3. Those are opposite reciprocals, so these two lines are going to be perpendicular. Now, number 8 is not going to be as obvious because the slope is not explicitly found in the equation, because both of these equations are in standard form. So what we'll need to do is change both of these to slope-intercept form so we can find the slopes. For this first equation, I could just subtract 8x over and rewrite this as y equals negative 8x plus 12. And so I can see that the slope of this first equation is negative 8. Now we can see that right here. So for the second equation, I'll start by, this one's going to take 2 steps, but I can start by subtracting 2x from both sides. Okay, so minus 2x plus 3. And then divide everything by negative 8. So that would be, let's see, 2 over 8 would reduce to 1 over 4, x, and then minus 3/8. That doesn't reduce at all. So the slope here is 1/4. So notice that these are not the same, so they're not parallel. They're also not perpendicular because they're not opposite reciprocals like we see in number 9. So these, they would just intersect, just 2 regular old lines intersect. They are neither parallel or perpendicular. For number 11, now we're starting to write equations. It says write an equation of a line that's parallel to 2x plus 3. So that's going to give us the slope. Parallel to 2x plus 3. That tells us that the slope has got to be 2. Right? It's got to be the same. And it passes through the point 3, 1. So this one we don't have in slope. We don't have the y-intercept. They do give us this point. But what we're going to have to do, just kind of talking strategy here, is we're going to start with point slope form. Okay. Then we are going to move around the terms and algebraically manipulate the equation into slope-intercept form. It is asking for this in slope-intercept form. So then change to slope-intercept form. Okay, so the point slope form is that y minus y1. So y minus The y1 is going to be this 1. It's the 1 in the coordinate, equals the slope 2 times x minus x1. So that's going to be minus 3. This is the equation in point slope form. And then if we want to get it into slope intercept form, I'm going to take 2 steps here. The first step is going to be to use the distributive property. Y minus 1 equals 2x minus 6. And then the second step is going to be to add 1 to both sides. We get y equals 2x, negative 6 plus 1 would be negative 5. All right, so there's the equation. It's parallel to 2x plus 3 and passes through this point 3, 1. All right, number 12. Write the equation of a line that is perpendicular to y equals negative 2x plus 1. Before we go any further, let's pull out what that tells us. It tells us that the slope is equal to positive 1 over 2. Okay? So positive 1/2, and passes through the point 2, 3 in slope intercept form. We're going to basically work it the same way that we did the previous one, where we will start with point slope form and then manipulate it into slope intercept form. So here we have y minus 3 equals 1/2 times x minus 2. Right? There's my y1, my x1, and my slope. I'm going to distribute that 1/2. So let's see, that's still 3. So it'll be 1/2 x. Let's see, 1/2 times 2 is 1, so minus 1. And then finally, I would add 3 to both sides, make this 1/2 x. Negative 1 plus 3 would be plus 2. Right, there's number 12 for you. Moving right along, number 13. Write the equation of a line that's parallel to y equals 1. Okay, so y equals 1, just to remind you, I'll sketch that out real quick, is a horizontal line. Okay, this one's actually pretty easy if you try to visualize it. Okay, y equals 1, we'll just say is like right about here. Here's 1. Okay, so if it's parallel to that, then it also has to be horizontal. So that means that the line we're looking for is just going to be y equals something. And if it's passing through this point negative 1, negative 3, which, just to put a point somewhere, negative 1, negative 3 is going to be somewhere down here, right? And so if it's got to be a horizontal line that passes through that point, you want to ask yourself, what's the y value of all these points? And it's just going to be this negative 3. So not a whole lot to this one. The slope is 0. It's just going to be y equals negative 3. Okay, there's number 13. Let's move on to the last page here. Number 14 says, write the equation of a line that's perpendicular to x equals 1. So x equals 1 is another one of those special cases. Just to help you visualize this once again, that's going to be a vertical line that passes through x equals 1. And so if it's perpendicular to that, that means that the line we're actually looking for is going to be horizontal. And it's got to pass through the point 1, 3, which is going to be, just roughly here. I'm just doing a rough sketch here just so you can visualize what I'm looking for. And so we're looking for this horizontal line. If this is 1 and this has got to be 3, so the equation that we're going to get here is going to be y equals 3. Oh, I thought that was the same number, but nope, the other one is negative 3. Okay. So yeah, y equals 3. Number 15 says, write the equation of a line that's parallel to 2x plus 2x plus y equals 5 and passes through the point negative 4, 3. The fact that it's parallel to this means that it's going to have the same slope, but let's rewrite this in slope-intercept form so we know actually what the slope is. If I subtract 2x from both sides, it gives me y equals negative 2x plus 5. So I know that the slope, since it's got to be parallel to this one, has got to be negative 2. So this tells me that the slope is negative 2. And it passes through this point. So this is where we're going to just write this equation in point-slope form. We got the slope and we got a point. And then change it. And actually, this one doesn't even ask us to change it. So I think we're safe to just leave it in point-slope form. How cool is that? Yeah. save us a little bit of time here. So y minus 3 equals negative 2 times x plus 4. It doesn't say write it in slope-intercept form, so we kind of did the bare, the minimum amount of work that would be required here. So we've got that ready to go. Now, if you were to rewrite this in slope-intercept form, I'll just give you what that would be. It'd be negative 2x. Let's see, what would that be? Negative 8 plus 3 would be negative 5. You don't have to write it like that, but that if you did and you're just trying to check to see if you got it right, this would also be correct. All right, number 16, it says find A. Oh, this one's a little tricky. So that ax plus 4y equals 12 is perpendicular to 4x plus y equals 3. Before we start messing with these, let's put them into slope-intercept form so we can start talking about the slopes a little easier. So for this one, I'm going to subtract 4x from both sides. And for this one, I'm going to subtract ax from both sides. I'm going to need to do one more little step here, and that is to divide everything by 4. So get negative a over 4. X plus 12 divided by 4 is 3. Okay, so let's think about what the slope should be. If they're supposed to be perpendicular to this one has a slope of negative 4. That means the slope needs to be positive 1/4. Okay, so this is going to be a little tricky. We need this little expression here. Here's the slope, right? This needs to be 1/4. So negative a over 4 needs to be 1/4. And we're going to solve this for a. A little tricky here, but I think we can knock this out. So first thing we're going to do is multiply both sides by 4, and that's going to give me negative a equals 1. And then if I divide both sides by negative 1, I get a equals negative 1. So a should be negative 1. And I think that about wraps it up for tonight's homework. So hopefully this helped you out. As always, reach out if you have any further questions. Thanks for watching, and you'll have a great day.